Hello, everybody. Once again, I am here with you for the other part of this elasticity. Now, today we will see what exactly the torsional pendulum is in the 12th standard. You have studied already what is to be as an simple pendulum is to be there. It is a little bit similar to that simple pendulum, but quite a difference as far as the torsional pendulum is going to be concerned. It is simply a disk is connected to the one fixed point. It is shown like this. Here it is to be there. If it is not clearly here, I will show you. This is what the case. I will shift myself here. So if you look at this case where it is to be as and this disk is to be there, round shape, and at the center, this point is connected to the fixed point, and such type of the horizontally connected heavy cylindrical either disc or you can say a rod may be there. If rod is also going to be connected, in that case it is also called to be as an our torsional pendulum is to be there. Now the thing is that wherever we are sorry wherever the uh, twist is given, in that case the whatever be the oscillations are going to be occurring, that is somehow uh, in the case where I am twisting that disk, it is in the either this is what to be as an your disk, and if suppose I am twisting it in one shape, and then obviously it will try to reget its original position and the oscillations will be occur. And this is what the condition where it is to be as in giving you a oscillations are to be there, regular oscillations are to be there. Now where I am the fixed point is to be there, and here is that disk is to be there, and when I am twisting it, it will again try to regain its original position because it is connected through the wire. And then what the oscillations are going to be occurring to be there. But the important thing is that what amount of the twisting is to be there, that is to be as a twisting angle. If I am twisting it for the smaller angle, the reflection or the reverse regaining is very slow. In that case, if I am twisting it for the larger angle, then it will be take the same reverse reorientation in the same fashion, and that is what the theta is going to be playing a very important role. And that is what the theta b is nothing but to be the angle, where the theta b the angle through which the wire is going to be twisted, and that is the oscillations are to be dependent on that how that angle is to be there. So this is what the simply as an your torsional pendulum, and you will get the oscillations in that case. But as the twisting is to be there, the restoring couple set up in it, because if I am twisting it for the smaller angle, then it will try to regain its original with the oscillations conditions, and that twisting couple whatever the setup in it is nothing but to be given with, as we have already calculated, the twisting couple per unit twist is nothing but to be pi eta r raised to 4 theta by twice L. Why there is to be as an theta is going to be included? Because the theta is the twisting angle through which it is going to be twisted, and that is why the twisting couple or the sorry restoring couple setup in it is nothing but to be given with c theta is to be there. And what is the amount of the c is nothing but to be, it is the pi eta r raised to 4 by twice L is to be there. So this is what the torsional pendulum and the oscillations or the restoring couple is set up in this torsional pendulum is to be there. Now the thing is that how to get calculate this c is to be where I already mentioned here or explained that part. It is the twisting couple per unit twist is to be there of the wire, and this will produces an angular acceleration. Now why there is come the words to be as an angular acceleration is to be there? As far as the acceleration is nothing but to be the velocity per unit time, that is to be the acceleration, linear acceleration. But as in the form of angle, when it is the velocity with respect to time in the form of angular fashion, then it comes to be as an angular acceleration is to be there. And for the disk it is in the angular because the twisting is in the form of a angular, and that's why this produces an angular acceleration. It is d omega by dt in the disk is to be there. And if suppose I now the center of the axis is to be there, and that wire is to be there, and I be the moment of inertia of the disk about the wire, and that is the inertia. Wherever you are not applying any external force, then it will not try to rechange its or original position is to be there, and that moment of inertia of the disk of the wire is to be there, and through which that is to be the, if I am applying how much amount of the twist or the couple is to be there, according to that I will get the twisting couple continuously set up, will set up in that torsional pendulum. And that's why I can write I d omega by dt is equal to minus of c theta is to be there. Now the question will arise why there is to be as an minus of c theta is to be there, as if I am twisting it in the from the left to right, definitely I will get the restoring couple in the other direction. That means it will come in the reverse way, it is from the right to left, and that's why the directionality proportionality is given with the minus sign, and that is why I d omega by dt is nothing but to be minus of c theta is to be there. And this is how I can explain, I can mention or correlate with the whatever be the acceleration into moment of inertia is to be related with the restoring couple is to be there in this torsional pendulum is to be there. As you are getting the regular oscillations or the simple harmonic motions, we have to find out the what is the time period, and to calculate that it is to be very simple to get this time period relationship, as with this case d omega by dt I can write in the fashion that is the c, it is d omega by dt is equal to minus of c into theta by I, and with this case I can again have the relation for the time period, and that is to be d omega by dt is nothing but to be angular acceleration, theta is to be the angular displacement is to be there, and simple as the simple harmonic motions are to be produced, then hence the time period is nothing but to be given with the relationship. It is simply as good as t is equal to twice phi under root of 1 upon c by I is to be there, and if you again simplify it, it will get twice pi under root of I by c, or we can simply say that it is t is equal to twice pi as an constant quantity, and we have the relation that is to be simply t is nothing but to be under root of moment of inertia of the disk, it is under root of moment of inertia of the disc or the rod, whatever it may be about the wire, and divided by the restoring couple per unit twist of the wire is to be there. So in this way you can calculate the time period for the torsional pendulum is to be there. So this is what the simple case and how this torsional pendulum is going to be working. So thank you for joining this session, and be at home and be safe. Thank you.